Hi everybody, here's Ned Coke for MIS5390. This is the second video of the fourth week of the course. The individual assignment is due by 1 p.m. tomorrow. I already have one entry by Angela describing the work that was done this week, and I expect most of you to be submitting by 1 p.m. tomorrow your individual assignment. I also expect by the end of this week, it's not in the syllabus, right? So it's not something that I am going to be very strict about, but I expect to get your project files and Excel spreadsheets with your data by the end of this week. Okay, you don't have to abide by this particular deadline, 1 p.m. on Friday, but if you can, that will be very good. If you cannot, try to do this by the end of the week. That's for the team leaders. One submission, two files, right, but one submission per team. One thing, there are a couple of things that I wanted to mention since there are no questions on the website. I wanted to mention a couple of things. One is that structural equation modeling is a general case of virtually all the statistical tests that are used and taught in schools of business, with one exception, which would be time series analysis. Those tests that you've seen in Stack's courses like ANOVA, UNCOVA, MANOVA, MANCOVA, multiple regression, path analysis, they are all done through structural equation modeling. So structural equation modeling is the most advanced, and you can do any of the others using SEM or structural equation modeling. And if you take a look at the textbook, so these are descriptions of the cases, the applications that you have videos for, and you also have the data sets. And so this one here is more of a multiple regression path analysis type of case. This one is multiple regression. This one is structural equation modeling proper because you have latent variables with multiple indicators. This one is a test that illustrates moderation. This one is more like a t-test or comparison of means test, which is equivalent to an ANOVA test. This one is rather unique. It's merchandising in a grocery store using WordPLS just to demonstrate what you would have in a specialized software that did that. So this is rather different from the others, but it's more in line with structural equation modeling. So this one is the one that is probably the most complex. So as you can see, there are 5 latent variables here, and 4 of them are measured through 3 indicators each, and 1 is measured through a single indicator. So these are these 3 indicators for these latent variables here. They are 3 different columns of the data set that are aggregated into this latent variable. That's why it's called a latent variable. This one we call the latent variable, but it's actually measured through only one single indicator. So we call it a latent variable, but it's not a proper a latent variable, because a latent variable is expected to aggregate more than one indicator. And as I said to you, this is this previous one here, this one. this is the best example of what I'm expecting you to have for your project, but with more variables, right? So this one has 5. I'm expecting you to have 7 or more. You don't have to have many more than 7. In fact, I wouldn't recommend too many variables, because if you have too many, the tendency is for them to become collinear with one another, or at least in pairs. So you may have to remove some from the analysis. So 7 is a good number. Let's say 7, at most plus 2. That would be 9. No more than that. That's not what I would recommend. Another thing I wanted to tell you is that what you're doing for this class in your project, model-driven data analytics, is the closest to, in the data analytics space, to what someone would do in a doctoral dissertation using structural equation modeling. In fact, if you go to workpls.com and click on publications and then scroll down to doctoral dissertations employing WordPLS, you'll see several doctoral dissertations in various universities that employed WordPLS. 2 that I would highlight are this one by Lee Brian Gaskins and this one by Murad Mokbel. And I mentioned Lee Brian because Lee Brian Gaskins is in industry. So he got his PhD and now he's a chief information officer for a university, but he's not an academic. At least his current position is not academic. So he is the director of IT for the University of Houston, Clear Lake. He was the director of IT here at MU when he got his PhD. I was his advisor. This doctorate got kudos, or he was highly regarded by Texas A&M College Station. He went there for review because he was a senior administrator here. So the system wants to make sure that the dissertation is legit, and you're not getting away with low quality work just because you're a senior administrator. He reported to the president of the university when he was doing his PhD. And Murad Mokmel is currently a tenured senior professor at UT RGV, UT Rio Grande Valley. So he is an academic. And if you go to his dissertation, just click on proceed. If you get to his dissertation, you're going to see that I also advised this one. And you will see that on the results, it's starting on page 81. So let me go there. Page 81, that's where he has the results. So he essentially shows a model here, a bunch of other results, right? But he shows a model that will look like your project models. It's a little bit more complex. So what he has here, and he did this, he did one analysis for Yemen and one for the United States. But this is a model with 3, 4, 5, 6, 7. Yeah, this is the same number of variables. He actually has control variables here. They are not indicated in the as separate variables, but they are actually separate variables. So if you happen to have control variables in your project, they would count as part of the 7 minimum that I'm mentioning. And given that his unit of analysis here was the individual respondent, the control variables are demographic variables, age, gender, etc. And these would be shown on WordPLS as variables measured through a single indicator pointing at the main dependent variable of the model. And this is actually usually a very important dependent variable, a very useful dependent variable to have in doctoral dissertations in schools of business. So this is his analysis. What he ended up finding is that social networking site use, like Facebook use, Instagram use, LinkedIn use, etc., influences job performance in a positive way through a number of intermediate effects. So quite interesting findings here. Now, you may ask, well, is this it to get the PhD? No, you have to do a lot of other things. So you have to, this is a close to 200 word dissertation, 200 page dissertation. So a lot of the work is setting the theoretical foundation for your model, hypothesis development, and so on. So it's a lot of work that precedes then the data collection, building the model with WarpLS, and then getting the results and then discussing them. So there's a discussion and conclusion. So it's a lot more for the doctorate than just collecting the data and doing a quick analysis with WarpLS and defending your dissertation. Now, what you are doing is similar though, because you are interacting with your client organization to find out what their theory is about their business and what they want to know through a data analytics, model-driven data analytics project. And quite often, going back to the textbook, quite often the biggest value you can provide is by providing an idea of how important the predictors are with respect to the main dependent variable in the model, the main criterion in the model, right? So, for example, courtesy here is the most influential in terms of satisfaction with delivery. Lateness is the second most influential. Cost is the third most influential, and packaging, quality of packaging, is the fourth most influential. And this allows the company to prioritize their intervention to increase this, to manipulate this variable. But going back to the dissertation, this leads me to something that I can tell you, which is that if you happen to want to do a doctorate in business, since you're doing your master's degree, you may be interested in doing a doctorate in the future. And there are many places in which you can do doctorates part-time, so you don't have to do it full-time. Typically, you have to live in the city where it's offered or nearby, unless it's offered in a hybrid or online format. Quite often, the places that offer doctorates that I would recommend, which are schools of business that are AACSB accredited. So these are schools of business that if you get a doctorate in them, any other school of business in the United States and elsewhere will regard that doctorate as a valid doctorate. Now, typically, it has to be called a PhD. If it's called a DBA or a doctorate of this or that, it will normally be perceived as an applied doctorate, which is also an option. But if you are interested in doing this, either the applied or the more research-oriented one, you are already preparing yourself to do that. So this model-driven data analytics, not only is it good for data analytics, applied data analytics for organizations, but it can also be used for you to do your doctorate, but in a different way. And one thing about doctorates in business is that typically you get paid to do them. So our school here, our School of Business here in Laredo, the Sanchez School, offers the opportunity for folks to do their doctorates in three main active areas that we have now. Management is one of them, finance is the other, and MIS and data analytics, that's your area, we also offer in that concentration. And you're going to get paid here. I think students are getting paid something like $21,000 if they are full-time with us. And tuition and fees while you're doing your coursework, full-time coursework, would be something like $10,000. So you get paid enough to cover your tuition and fees and then have some extra. So that's an option that is open to you. I know this, you're probably more concerned about getting done with this course and doing your project. So this may be too much information right now for you. You're probably busy, but be aware that that's a possibility. And if you go there to dissertations, you're going to see that people do doctorates in other areas, not only in business. In fact, the ones that I have listed here are mostly in business, but people do doctorates in all kinds of social sciences, nursing, healthcare areas as well, using WRPLS, which means to say that they use structural equation modeling. WRPLS is one of the tools that enables structural equation modeling in a relatively easy way, right? There is another tool called AMOS that is much more difficult to use. It's difficult to set to choose the settings so that you get the data analyzed correctly. So, okay, that's what I had for today. Thank you for watching.